Hello everyone, I'm Mohammed Ahmed, and this is my computer channel. This is my computer science study center channel for CAIE and O level and A level. So basically, today it's a first video. So today I'm not going to go for anything very much special. So over here, what we are going to actually discuss over here is um, the system that we are going to follow. The system that we are going to follow is about how we are going to go with our roadmaps. So the roadmaps map for completing the whole syllabus. So there are about 10 chapters. There are about 10 chapters, and these 10 chapters are divided into 10 parts. So in 10 parts there are different contents, and those contents can be needed for 10 to many, like I would say that it would take 2 months to finish, 2 months to complete the whole chapters and with the whole book syllabus. So over here in chapter 1 we will take only 2 days. In chapter 2 maybe we are going to take 1 day, and then for topical revisions and past papers I told here, because we're going to do for the revision series, and also we're going to go for the topical questions and answers, so that whenever I'm doing a topical answers or questions, that time I'm going to show the mark scheme, how they actually mark them, how they actually um, systemize the things like A1, C1, B1, so whatever those um, marking systems are. So the first topic is about only 2 days or 1.5 day, I would recommend. So next of all, which is chapter 2, which is about all data transmission. In chapter 1, we are going to learn today. Today we are going to actually supposed to go for the roadmap, but in roadmap we are not going for it, because I will just I will just remind you every videos when I'm going to actually like give it. So in roadmap we have data transmission. I mean data representation, where I'm going to take it only for 2 days or revise these chapters. There may be 1.1, 1.2, and 1.3. So these are all the topics which are going to learn in this chapter of this. So let's move on to chapter 1. What we are going to learn today, it's about data transmission, data representation. So in data representation, we have the syllabus over here. That what our syllabus says, why the computers uses binary system to represent all forms of data. They understand the binary, hexadecimal numbers, convert them to positive binary, binary, hexadecimals. So over here, these are basically the maths. Then over here we have another maths. These are the maths. These are maths. These are basic maths. So we just have to just know some basic concepts of it, and then we are going to go for. Then over here there is overflow. There's overflow. This is also a very over there. Maybe in 2020 or 2021, there are a lot of questions from there. So there are some notes and guidance where you must read those, whatever this is, because all of this from the book, in the notes and the books, and what are the notes I'm going to keep right now. So there is another one, which is these are also maths. Let me show. These are also maths. We are going to perform a lot of the things over here. So there are logical shapes. Logical shapes. How do we perform logical shapes? Left, right shapes. We are going to take 2 days, and today we are just going to go for some review of the topics with some maths. Like today we are going to actually basically do only this much. I think we can complete this much, because In topical past papers, when we are going to go for the topicals, that time we are going to make a lot of progress, because in topical past papers it's very much easier and very much not that difficult. Like if we show 2 to 3 maths, you will be able to easily cope with the other ones. Like it's easier, easier. In chapter one, it's just the basics. You just no need not to worry about anything at all. Alright. Over here, there is over here. Let's go for it. Um, okay, so binary. Binary is a base two system. Must know it because every binary numbers are 0 1 0 1. Like these are actually binary numbers. Zero and ones are the only foods that a computer can actually take. Like these are only for computers. Computers. So it's written already over here. So that binary is a two base two system. Then it only contains 0.01 and ones. Like it only contains zero and ones in the computer. Any data needs to be converted to binary before computer can use it. And then data is processed by logical gates and stored in registers. Obviously, just to have to like read it, read. Don't actually memorize anything. Just memorize these things. Memorize. The computer is a type of memorization, or you could say that a computer science is actually kind of memorization in read and read, nothing else. Then you have the difference between the binary and ternary and hexadecimal, like how they are actually like to denote it. So over here we are going to see in the next part. All right. So ternary number. Ternaries are for the human system, because 1 2 3 4 5 6 7 8 9 10 are everything blah blah blah, what are the numbers are all for the human things. So 1 plus 1 2 2 plus 2 3 2 plus 2 4. So like these are the binary things. Like whenever we are actually like counting or measuring or performing any maths, that time we are actually like using this already where it's written. Humans uses dinner to this. Humans uses dinner system for counting, measuring, performing maths calculations. Dinner is 10 base system, then 0 to 1 to 8 to 9 10. Easy to read, easy to. These are the advantages. Then yep. So these are the things you must have to know. And hexadecimal, just read the book and also read the notes which I'm going to actually like provide in the Google Drive, so that you can find it in the description box right in the below. All right, so over here is the hexadecimal. It's both for the humans and the what I should say, binary. I mean, hexadecimal is a short form of for the humans to understand, and also it's a short for the binary system to be what's less storage must be required. Like debugging would be very much easier. So over here, you can see that the 16 the system, then the 0 to 9 and 8 to 10 is basically A, because these two numbers are so much big that a computer cannot hold properly. So they convert them into A, B, C, D, E, F. So over here 10 is A, 11 is B, 12 is C, 13 is D, E, and 14 is. Wait, I think I made a mistake. Wait. My bad. Wait, let me do it again. 1 second. Um, Over here, let's write it. You must write it too if you want to. A is 10, B is 12, B is 11, C is 12, D is 13, E is 14, and F is 15. So these are the things. These are the numbers which are converted to binary. I mean, which is converted to um, I mean hexadecimal. So hexadecimals are the values which are actually in letter format. That's the thing. Like it's easier to write and read. It's easier to debug, and these are used in MAC address, IPv6, HTML, color codes, used in assembly language and error codes. So these are the things you must remember. Like just memorize it. so that if any question comes like this, you must be able to answer them easily. So hexadecimal shorten and lex takes place for the computer. So that's why we are actually using the hexadecimal instead of binary. Because when these are converted to binary, that time the computer might crash or something like that happens, blah blah blah. So that time we are actually like converting them to hexadecimal, so it's easier for humans to understand. Also, it's for easier and shorter for the computer to store. So that's the thing. Also, it's easier for the any other persons to cope. Alright. So these are the binary, denary, and hexadecimal. I just copied it from the ChatGPT so that it's easier for us to like understand. Even though it's not that much needed, just read it, read it. I would recommend not to memorize much, just to read it, because in CAIE, in question papers, you will be able to have to write two or three points for it, like what is it base. They must ask you about the base. Like in mark schemes, you will be able to understand it. Like they will give you base, like talk about the base, like base of the binary or hexadecimal, base of the binary or denary, or base of the binary and hexadecimal, denary and hexadecimal, whatever. They might talk about the digits. So in there will be some possible answers for the difference and difference of binary, denary, and hexadecimal. So you don't have to write if you don't have to memorize everything. Just remember base, then digit used, like zeros and ones, 0 to 9, A to F. Who uses it? It is used by the computer. Not that much needed. Ternary for humans and programmers. Programmers are humans and computers next up. So very long, medium, and short. Not that much like needed for to write. I hope so. And difficult to for humans, easier and easier than binary, whatever it is. All right. So next we are going for the conversions. So we are going to just do only 6 conversions today and end of this uh, video. So let's start with the conversions. There will be more conversions where I will be giving it in the topical papers after the lectures are finished. Like after the chapters are finished, that time I'm going to actually like give whatever I have to. Alright. So let's move on to the um, next one over here. So which conversions we are going to do first? Alright. So binary to denary. So let's go. Number one is binary to denary. Denary. All right. So in binary to denary, what we actually do: 0 1 0 0 1 0 0 1. So over here, 1 2 3 4 5 6 7 8. So whenever you are actually like writing any numbers, that time must have 8 digits, not more than 8 digits. So it would be very much tough for you to like cope actually. So we are actually converting it to denary value. Denary. So how we are going to do it? Let's see. The shortest method, the most easiest method, is to memorize this thing: 128, 64, 32, 16, 8, 4, 2, 1. Memorize this thing, nothing else. Just memorize and just read it one and one again so that you can memorize it easily. Memorize it. Memorize it so that you can easily understand what you're actually like doing actually. All right. So whenever you're going to do many maths, just memorize this thing, because if you memorize this, like it will be easier for you to in the exam paper to write it easily, because there are other methods, but I prefer this method is the best. All right, let's move on to the every teacher would recommend this method, nothing else. All right, let's move on to the next one. We over here, what we're going to do is put the values in here. So 0 1 0 0 1 0 0 1. So we're just going to add them: 64 plus 8 plus 1. So 64 plus 8 plus 1. We are not allowed to use calc calculator. So must not use calculator. Alright. 64 plus 8, which is, let's do it, just doing it. And it's 73. I'm just counting it, nothing else. Alright, let next is, so this is the one math which I have done from the denary to binary. So this is the denary number. So this is the denary. They will give us space over here, just to have to like write it. They will give us space like this way, 100 1001, and then you have to actually like, what should you do? Like just write 73 in the space. That's it. All right, let's move on to the next one. Um, let's move on to the next one. All right, so over here, next one, which is about, what should I say? It would be denary to binary. So it would be, denary to binary. So denary to binary. Binary. So denary to binary. So now suppose we have, 70. So we are going to convert the 70 to, so we must memorize this thing. So 128, 64, 32, 16, 8, 4, 2, 1. So over here, you have to check if the number is greater. If the number is greater, then you must subtract. If the number is not greater, you must not subtract. That's the thing. If the number is not greater, then you must not subtract. If the great number is greater, then you must subtract. So this number is greater, but this number is not greater. Then you cannot subtract it. So we put 0 over here. Alright. This number is smaller and this number is greater. So must subtract it. So 64 minus 7 is 64, I mean 70 minus 70 is 70 minus 64, each it is 6, right? And 64 minus 7, 64, I mean 70 minus 60 is 64 is 6. Alright. So this 6, I mean 6, I'm sorry, my bad. 70 minus 64 is 6. So this 6 is the another number, and is 6, is 32 is smaller than 6? No, it's not smaller. It's 32 is bigger, so we are just going to put 1 over here because we have 64, so we can add 1. We can add 1 over here because it's subtracted. It can be subtracted, but this number is not subtracted, we will put 0. This number is cannot subtracted, we will put 0. This number in this number is not subtracted because 2 minus over here. So and this number is subtracted because 6 is greater than 4, so we will put 1 over here, and 64 minus, so we will get it as 2. So 2 minus 2 is also subtracted, so 1, and 2 minus 2 is 0, and 0 is not greater than 1, so we'll put 0 first. So this is the number 0001 double 0. This is the binary. That's it. All right, let's move on to the next one. It's about, binary to binary. So now we're going to go for binary to hexadecimal. Binary, binary to hexa. So suppose the number is this. This is the number we have. And suppose we want to double one. This number is the. With this number we are going to convert it. Let's go for it. 1 0 0 1 1 0. So this is actually the chance 1 2, over 0 0 1 0 0, and then this is the number. Okay. So what we are going to do is, in hexadecimal, it's very much easier, more than denary. So we're just going to 1 0 0 0, split it into 4 parts, 2 parts. So one part is this, another part is this. So we're just going to split it 0 1 1 0. So after splitting it, we're just going to put 8, 4, 2, 1, because there are only four numbers from the, yeah, uh, 8, 4, 2, 1. All right, so this is adding 2 plus 2, 4, 4 multiplied 2 is 8, like this way. So what we are going to do, we'll check it out. So 4 is there, so 4, we'll put the 4 over here, and then we have 4 over here, so 4 plus 2 is 6, so it's only 46, and this 46 is the hexadecimal number. Maybe I could have shown another math, but right now we are starting time, so we're going to move faster. And in past topical past papers, we're going to go for more things. Anyway, so let's move on to hexadecimal to binary. So suppose in hexadecimal to binary, hexa to binary. In hexa to binary, what we are going to do is in hexa to binary. Suppose we have A, C, B. I mean AC, only AC. Alright. What's the value of A? Its A is 10. What is the value of C? The value of C is 12. So what we are going to do is just put 10 up and put 12 over here, and put 8421. 8421. 8421. The last maths, like we're splitting it half. So this time we are also again splitting it half. So 10 minus 2. Is it subtracted? Yes, it's subtracted. So we'll put 1. And the is for so after subtracting 10 minus 8, so it comes as 2. So 2 is 2 subtracted with 4. No, it's not. So 0. Is 2 subtracted with 2? Yes, it's 1. And is 0 subtracted with 1? No, it's 0. So in 12, is 12 subtracted with 8? Yes. So it comes as 4. My bad. Over here we'll put 1. And is 4 subtracted with 4? Yes, it's subtracted with 4. And we'll put 1, and we are, you can see that 0 0, so 0 0, so done. So 1 0 1 0 1 1 0 0, it's done. Next we are going to move on to the next one. Next we are going to move in the next one, which is, my bad, sorry, I mistakenly um, all right, next conversion is the last conversion, which is hexadecimal to denary. So hexadecimal to denary, how do we do that? Hexadecimal to denary. So in hexadecimal to denary, we are going to do is hexa to denary. Denary. So in hexa to denary, what we are going to do is hexa to denary. So in hexa to denary, suppose we have a number which is AC. Only and suppose we have a number A1. We have A1. So in A1, what we can do is just put all the numbers 10 and 1. So 8, 4, 2, 1, 8, 4, 2, 1. So it's 1 and 0, 1, 0. And over here 0, 0, 0, 1. So what we're going to do is just put this number 1, 0, 1, 0, 0 0 0 1. So we have to memorize this again. Once again I'm telling it: 148, 64, 32, 16, 1 for 148, 64, 32. What my bad, one was 128, 128, 64, 32, 16, 8, 4, 2, 1. So over here what we're going to do: 1 0 1 0 0 0 0 1, right? Okay, so 128 plus 32 and plus 1, I mean, yeah, plus 1, whatever it comes, it's the number. So 128 plus 32 plus 1, which comes as 161. So it will be 161. 161. So over here, next we have um, next we have another maths, which is next we have the last maths, which is about. Let me check it out. Over here we have done everything: hexadecimal to denary, and then hexadecimal to binary, and hexadecimal denary to hexadecimal. This is on the left, and these are done. So denary to hexadecimal. Let's do this. Denary to hex. So in denary to hex, what we have to do is denary to binary, and then to hex. How do we do it? So let's suppose we have a number is 113. So in 13, what we are going to do is 128, 64, 32, 16, 8, 4, 2, 1. So what we're going to do is 0, 0, 0, 0, 1. So 13 minus 8. So it's 5. So 5, 4 minus 5, it's 1. So over here 0 and 1. So this is the number. So we are going to just split it half. So we are just going to 0, 0, 0, 0, then 1, 1, 1, 1, 1, 0, 1. So 8, 4, 2, 1. So it comes as 0. 8, 4, 2, 1. So over here 8 plus 4 is 9, 10, 11, 12, and 13. So 13 is what? D. So it will be 0D, which is hexadecimal. Well, thank you, everyone. So this is the only thing we are going to learn today. So hope you like this video. So please subscribe, and the next part is coming soon at Friday. Please wait for it so that you can be able to see this video once again. And please don't remember to like this video and subscribe. Thank you very much.